friends. Today I'm here with a Cournot model, exercise on a Cournot model. Now Cournot model is one of the oligopoly models. Alright? Okay, let's start off. A homogeneous products duopoly faces a market demand function given by P equals 300 minus 3Q, where Q equals Q1 plus Q2. Both firms have constant marginal cost, so MC equals to 100. Alright? Okay, so the first part says, what is firm 1's profit maximizing quantity given that firm 2 produces an output of 50 units per year? What is firm 1's profit maximizing quantity when firm 2 produces 20 units per year? Alright, so what do we do? With two firms, demand is given by, so we clubbed it. So the function was P equals 300 minus 3Q, where Q is Q1 plus Q2, right? So we just substitute that expression out here. So it's P equals 300 minus 3 Q1 plus Q2. So that gives us 300 minus 3Q1 minus 3Q2. So I just opened up the brackets. Now it says that if Q2 equals 50, so if firm 2 is producing 50 units of output, then what is firm 1's profit maximizing quantity? So then I substitute the value of Q2 out here. So I get P equals 300 minus 3Q1 minus 3 into 50. So I get 300 minus 3Q1 minus 150. With subtraction, I get 150 minus 3Q1. So now my function becomes P equals 150 minus 3Q1. Since they are asking for profit maximizing quantity, so we have to set the condition for profit maximizing. That's MR equals MC. Alright, so we have MC, which is given in the question, that's 100, but we don't have MR. So we'll derive our MR, right? We have been given the price function or the demand function, right? So we derive our MR from this. How? Let's see. So total revenue, we know TR is equal to P into Q1, since I am calculating this for firm 1, right? So that's why I have taken not Q but Q1. Okay, so P for Q1 is given to be this one, 150 minus 3Q1, correct? Given that Q2 is producing 50 units, firm 2 is producing 50 units per year. Okay, so 150 minus 3Q1 into my Q1. Alright, so I get 150 Q1 minus 3Q1 square. Simple. I'm just multiplying it, right? Distributive property. Now what is MR? MR is nothing but marginal revenue, which is nothing but the slope of total revenue, which is nothing but the derivation of total revenue. So that's what I do. I differentiate or derivate, right? So I am derivating total revenue with respect to Q1. Okay, so I get, applying derivation rules, I get 150 minus 3 into 2, that's 6Q1. Okay, so that's my MR. Now MR equals MC, that's my profit maximizing condition. So I just substitute their expressions or values. MR, I have got 150 minus 6Q1 equals MC, that's 100. So I just take it on the other side and I solve it. I get Q1 equals 50 divided by 6, that's 8.33. So that's my profit maximizing quantity for firm 1 when firm 2 is producing 50 units per year. Hope you understand, right? Now similarly, I'll solve for Q2, that is when Q2 is given to be 20. So instead of 50, it's just 20, and the rest of the procedure or process is the same. So if Q2 equals 20, then P is what for Q1? So it will be 300 minus 3Q1 minus 3 into 20 now instead of 50, right? From here. I have taken it from here. Correct? Okay. So I get 300 minus 3Q1 minus 60, and I get 240 minus 3Q1. Now again, I have my MC, but I don't have my MR. In this case, when firm 2 is producing 20 units, all right. So again, I'll solve. So TR will be P into Q1. So this time my P is 240 minus 3Q1 into Q1. So I get 340. Sorry, I'm so sorry. So it's 240 minus 3Q1 into Q1. So I get 240 into Q1 minus 3Q1 square. And so I derivate that again. I get my MR, which is 240 minus 6Q1. Again, setting MR equals MC, I get 240 minus 6Q1. This time this expression equals 200. That's my MC. That's given in the question. So I get my Q1 equals to 140 divided by 6, which is equal to 23.33. So that's my profit maximizing quantity for firm 1 when firm 2 is producing 20 units of output. Do you understand this? Hope you do. Alright, now part B. Part B says derive the equation of each firm's reaction curve and then graph these curves. Alright. Okay, so what do we do in this? So reaction curve for firm 1 will be a curve, or you can say an expression where I have to write an expression Q1 in terms of Q2, right? As we go, you will understand. Okay, let's start. P equals 300 minus 3Q1 plus Q2, right? That's my demand function given earlier. So I just open up it again. So it's 300 minus 3Q1 minus 3Q2. TR P into Q1, right? Since I'm finding the reaction curve for firm 1, so that's why Q1, okay? So 300 minus 3Q1 minus 3Q2 into this whole Q1. Now here I'm not substituting any Q2 values because it's not given to me, right? They just want a expression, a reaction curve, okay? So I just open up the bracket and I get 300 Q1 minus 3Q1 square minus 3Q2 Q1, okay? My MR would be nothing but the derivation of this TR, right? And since I'm finding it for just firm 1, so I will derivate this expression, my TR, with respect to Q1 only. Okay? So I get 300, I get 6Q1 minus this, applying your derivation rules or differentiation rules. This becomes a constant if I'm doing partial derivation and I'm derivating just with respect to Q1, so I get minus 3Q2. Setting MR equals MC, I get this is my MR, so that's my MR. My MC is given out to be 100. So I just now substitute these values. I just write this expression and just solve for Q1. Not solve for Q1 and Q2, but write an expression Q1 in terms of Q2. All right. So with some rearrangements, I bring this here. I get 300 minus 100 minus 3Q2. I take this the other side. 6Q1. I get 300 minus 100. That's 200 minus 3Q2 equals 6Q1. I just divide the entire expression by 6. So I get 200 divided by 6 minus 3 divided by 6 Q2 minus equals to Q1. So I get 33.33 minus 0.5 Q2 equals to Q1. So in other words, Q1 can be written as this. Q1 equals to 33.33 minus 0.5 Q2. Now this is your reaction curve for firm 1. So this is what I mean, that you have to write an expression of Q1 in terms of Q2 for the reaction curve for firm 1. Now similarly, we have to find the reaction curve for firm 2. So that would be an expression for Q2 in terms of Q1. Now in this case, since the MC is same for both the firms, so symmetry applies, and so we get the same expression for Q2. If you want, you can solve it. You'll get the same answer, right? Because of the MC being same, okay? So Q2 equals 33.33 minus 0.5 Q1. Now these two are the reaction curves for firm 1 and firm 2. Graphically, these reaction function appears as what? Alright, so some graphing here. So we have this. I have firm 1 quantity on my x-axis. I have firm 2 quantity on my y-axis. What am I doing? I'm just, let's say, for the reaction function of firm 1 or curve for reaction curve for firm 1, right? Just substitute 0 out here. So you'll get two intercepts basically, okay? So 0.5 if I substitute Q2. So if I substitute Q2 out to be 0, then what do I get? I get 33.33, right? That's my first point, first intercept for reaction curve for firm 1. Look at very carefully, okay? That's what I've done. So first of all, I'm repeating again, I'm substituting 0 for Q2 so that I get an intercept for Q1. Okay, so when I do that, I get my Q1 as, so Q2 being 0, then I get my Q1 as 33.33, correct? Okay, now in the same expression, you substitute Q1 as 0. If you substitute Q1 as 0, you will get Q2 as 66.66. That is, so Q1, since this is firm 1 quantity, so Q1, if Q1 is 0, so if Q1 is 0, I get Q2 as 66.66. These two are the intercept for reaction curve for firm 1. So you just join these two. Okay? Alright? Similarly, you will do for reaction curve for firm 2. So you'll get the same answers. It's just that the intercepts would be at different places, right? Now when I substitute Q1 in this case as equal to 0, so I substitute Q1 as equal to 0, I get Q2 as 33.33. So 33.33, that's what I have marked here. So be careful while doing it for both the firms, right? Because the numbers would be same, but the graph would be different. The curves would be different actually, right? The intercepts would be different, okay? Now in this, again, if I substitute Q2 equals 0, so if I substitute this Q2 equals 0, I get Q1 as 66.66, right? Okay. All right, so you just join these two intercepts for firm 2 reaction function. So joining this and joining this, you get a equilibrium in the center, and that's your Cournot equilibrium. Okay? All right. Okay, mathematically, how can we derive that Cournot equilibrium? That's the next part. So what is the Cournot equilibrium quantity per firm and price in this market? So because of symmetry in equilibrium, both firms will choose the same level of output. Thus, we can set Q1 equals Q2, right? So Q2 is, take any one of the reaction curves, right? I've taken the Q2 one, so Q2 equals 33 minus 0.5 Q2. So instead of Q1 from here, I have substituted Q2 because I have set Q1 equals Q2 because of the symmetry. Okay, and because of that, the firms will choose the same level of output. So Q1 is equal to Q2. So I've taken this reaction curve for firm 2. That's Q2 equals 33 minus 0.5 Q1, right? That's the reaction curve. Now, since Q1 is equal to Q2, so that's why instead of Q1, I have substituted Q2 so that I have an expression in one variable and I can solve for that. Okay. All right. So now solving for this, I bring this to this side. So I get Q2 plus 0.5 Q2 equals 33.33. Solving 1.5 Q2 equals 33.33. So Q2 gives 33.33 divided by 1.5 and we get 22.22. That's the answer. Now, since both firms will choose the same level of output, both firms will produce 22.22 units. So that's their Cournot equilibrium. And that's their profit maximizing level of output. How do we know that? Because we have solved these reaction curve with setting MR equals MC, right? So we need not do that again. Do you understand my point? Okay. Now the price, I just substitute these two values in the demand function. So that's given to be P equals 300 minus 3 Q1 plus Q2. So instead of Q1 and Q2, I'm just substituting the values of 22.22. So this is what I get. 300 minus 3, 22.22 plus 22.22. I get 300 minus 3 into 44.44. Solving that, I get 300 minus 133.32, and the price I get is 166.68. Very high price. So that's the price in the oligopoly market that will be there if there are two firms behaving like this as in the Cournot model. All right. Now let's just compare this, that is their equilibrium quantity and their price, with some other market structures. Okay. So my next part says, what would be the equilibrium price in this market be if it were perfectly competitive? Now, if it's a perfectly competitive market, then the equilibrium occurs at P equals to MC, right? Why? Because in a perfectly competitive market, your P is equal to your MR, right? So P is equal to MC. So now P is nothing but your demand function. That's given 300 minus 3Q equals 100. That's your MC, that's given in the question. Solving for Q, you get Q equals 200 divided by 3. That's 66.66. So can you see that the equilibrium quantity in perfectly competitive market will be much higher as compared to your equilibrium quantity in Cournot model. Each firm producing 22.22 units. Together also they make 44.44 units, right? But if they are in perfectly competitive market, the equilibrium quantity would be much higher to 66.66. All right. Okay, and what would be the price here? Since P equals MC, right? So MC is 50, so your price would be 50. Right? In this case, the price would be 50, but here your price is coming out to be 166.68. Quite a lot of difference. All right. Okay. The E part says, what would be the equilibrium price in this market if the two firms colluded to set the monopoly price? So now what happens when two firms colluded, then your demand function basically becomes this. So it's no longer Q1 plus Q2 since they have colluded. So P equals 300 minus 3Q. Profit maximizing condition in a monopoly is the same as MR equals MC. So in this case, what will be our MR? TR is again P into Q. So we'll calculate our MR from this. 300 minus 3Q into your Q. So I get 300Q minus 3Q square. I get my MR as, I derivate this, applying the differentiation rules, I again get 300 minus 6Q. So this MR equals to my MC of 100, I get Q equals 33.33. So the output is much less, right, in a monopoly. Okay, so here if they colluded, then they would be producing together, they would be producing just 33.33. Together in a Cournot model, they would be producing 44.44. And in a perfectly competitive market, they would be producing 66.66. Correct? All right. However, the price, let's see what's the price would be. So at this quantity, P is equal to 300 minus 3. So I'm just substituting the value of Q out here, right, in this function. So it's 300 minus 3, that's 200 divided by 6. So that's what I've written. And so that goes as with all the cancellations. So 3 2s are 6 and 200. So 300 minus 100, so that gives me 200. Okay, so 200 would be the price if they collude and act like a monopolist, right? So that's a very high price. So to give you just a summary of all these three things, I'll just write, let's say, so this is the market structure, right? This is the price and that's the total quantity. So I'll just go for the total quantity, right? So if the market structure, let's say if the market structure is Cournot or oligopoly, right? Cournot model. So if the market structure is Cournot, our price was 166.68 and the total quantity produced by both the firms together was 44.44. If the market structure is monopoly, so we get the price as 200 and we get total quantity produced is 33.33. If the market structure is perfectly competitive, so I get my price as 50 and my total quantity as 66.66. So can you see the difference? So from the consumer's end, right, the perfectly competitive market is the best one, right? Okay, my last part, my F part says, what is the Bertrand equilibrium price in this market? Now, if the firms acted as Bertrand oligopolists, the equilibrium would coincide with the perfectly competitive equilibrium of P equals 100. Okay, P equals MC. So it will act like same as like a perfectly competitive market. All right. Hope you find it fruitful and productive. See you next time. Bye-bye.